My name is Kush. I work for Dr. Scott Kenney at Center for Food Animal Health. And today I will be talking on hepatitis E virus. Oh, wait. Did you hear hepatitis E? The answer is yes. You may have heard hepatitis B and C making headlines, but today you will know more about hepatitis E virus. So before getting into this electronic microscopic picture, I want to tell you a short story, like how they found the first electronic microscopic picture of hepatitis E virus. So once around 1987, Russian military was sent to Afghanistan. So it was the general posting of the military. And then there was an outbreak of this virus. At that point, it was called non-A, non-B hepatitis virus because it was neither A nor B, but it was almost similar. So at that point, there was one of the graduate student called Dr. Brian. So he just informed to his PI or the research institute where he was working, like there is an outbreak. Can we get a sample from Afghanistan to Russia? You all know the answer. What would be the answer? The answer is no. You cannot bring a virus from the underdeveloped or the developing country to us. So what he did, so he had all the samples, almost 9. So he pooled them and mixed it in a yogurt. And he ate it. And that's how the virus came to Russia with him. And on the 36th day, you will believe it or not, he developed acute hepatitis. He was in a very serious condition. And that was the first time. His samples were taken on the 28th day, 36th day, and the 42th day, and they saw virus-like particles, and how we came to know the electronic microscopic picture of the hepatitis E virus. And at that point, it was called hepatitis E, not non-A or non-B hepatitis virus. So hepatitis virus exists in 2 forms. On the left side, you can see naked, and on the right side, you can see envelope, the outer coating. So let me say you something about the naked virus. So as the name suggests, hepatitis means inflammation or swelling of liver. The natural transmission route is through the contaminated food or contaminated water. So you may have guessed the virus would excrete in the feces. And in the intestine, we have the digestive juices that actually destroys the outer coating of the virus. That's why in the feces, we have the naked virus. And in the blood, we will have the virus with the outer coating, which they refer as quasi-envelope. So as I am talking about the multiple routes of hepatitis E virus infection, let me go from the first one, the fecal-oral route. In the picture, you can see a pig drinking water from a small pond. At the same time, slightly on the right, you can see those water gets connected to the huge ponds, and you can see a girl taking a water from the pond. So most of the time, in underdeveloped and developing countries, the hepatitis E virus transmits through drinking water. And when we see on the right side, what about the developed countries now? So in the developed countries, the transmission route is through blood transfusion and also through the contaminated meat product. So what are the meat from where we can get hepatitis E virus? We can get it from pig, can get it from pork, can get it from rabbit meat, camel meat. So from here, the message I want to give is the zoonotic virus, which means the virus that can come from animals to humans. So there should be a reservoir. So what is that reservoir? So you can see multiple animals there, but we have the major reservoir as pig because that's the meat the world is consuming. It's like a second protein source in the world. So with all the viruses, we always think about, do the virus have the ability to cross generations? Which means, can the virus cross the barrier that separates a mother from fetus? That is, in the scientific term, we say, can it cross placenta? The answer is yes. So there is a vertical transmission seen from mother to child. So from here, just take a picture that in underdeveloped and developing countries, the transmission is through contaminated water. In developed countries, the transmission is through contaminated meat products or through the blood transfusions, which have been a problem mostly in the European countries. So with hepatitis E virus, if I say a lot, you ought to be thinking like why it's not making a headlines, why we cannot hear in the news like or in Instagram about the hepatitis E virus. The reason for that is it's called a self-limiting virus. So just let's separate a pregnant woman and immunocompromised people and just say if a person is healthy, he or she will never get any or never feel any symptoms of the hepatitis E virus, because you can see on the left there are non-specific symptoms. Non-specific means it's not specific to hepatitis E virus, and it's just like in 1 week you will feel normal. So you felt like you got a common cold and it just went off. But what it does to a pregnant woman, why the virus is so virulent to pregnant women. You can see in the pregnant population, we have the maternal outcomes as well as the fetal outcomes. So from there, I will not go in every word, but just make a picture that when it affects maternal population, it causes most of the nerve signs, neurological symptoms, and also the hepatitis. As the name suggests, hepatitis, inflammation or swelling of liver. What happens in the fetal side? Fetal side is like low birth weight, miscarriages, and also leads to death. So major target population of hepatitis E virus is pregnant women, particularly during the 3rd trimester of pregnancy. And the reason behind that, still we don't know. That's why we are studying hepatitis E virus, because we need to find out what is the reason that is causing this virus to be so much dangerous to the pregnant population. So this is just a report, one of the reports from multiple countries, starting from 1987 to almost 2017. So you can see the different colors represents different countries. So the first country that you see, it started from Nepal, 1987, and Nepal and India, they are the border countries. So you can see even in India, it starts at 1987, which makes sense. So Nepal and India are the border countries, and initially, and even today, most of the places you will not find a bottled water. People are still relying on the water from streams. And this is one of the reasons that I am here, because I belong from Nepal. And that's what motivated me to work with hepatitis E virus after I completed my veterinary degree. So I wanted to come to a graduate school where I could study the hepatitis E virus. And the first case that was reported in 1987, and again it was in 2006. And I'm sure there may be multiple numerous cases which got never diagnosed as hepatitis E virus in Nepal. One more thing that I want to let you all know, all the countries that is listed here, they are almost underdeveloped or developing countries. Why I am focusing on this? The reason, as I said, the transmission route, mostly in the underdeveloped and developing countries, it is through the contaminated water. And that's why you cannot see here the developed countries in the list. One more reason for that, this graph is showing you the number of the pregnant population having the mortality. So the strains that gets transmitted from meat and blood products, they do not cause pregnancy mortality. So only the strains that gets transmitted through contaminated water produces pregnancy mortality. So from here you can just think, oh, that means there is a viral factor as well playing a role. So let's see, where does the virus replicate in the pregnant woman? So one of the organ you can see, as it says, it goes through the fecal-oral route. So the first multiplication will be in the intestine. And then it also crosses the placenta. So you can guess, oh, it also replicates in the placenta. The name suggests hepatitis, which means swelling or inflammation of liver, so it also replicates in the liver. and also the maternal-fetal interface. So it's just a barrier that separates the fetus and the mother, just like placenta. So maternal-fetal interface is just like maternal side and the fetal side of the placenta. So it also replicates there. So now, again, the question comes here. Pregnancy is considered a normal. Pregnancy is not abnormal. So we have lot and hundreds and thousands, millions of viruses in the world. Why this virus is so specific to pregnant women? We don't know the answer. So have they done research on this? Yes. As we know, when the SARS coronavirus 2 came, a lot of labs were trying to develop a model. They checked from non-human primates to the lower level as mouse. And finally, they found, okay, the hamster works better for the SARS coronavirus 2. So the same thing we did, a lot of people did with the Hepatitis E virus, various models, from the non-human primates to the mouse. But I have listed some of them here, and I want you all to focus on, I have also listed human. So you can see in human, it causes maternal death, it causes stillbirth, miscarriage, premature delivery, and vertical transmission. Why I'm focusing on this? Because a model can only be used when it almost recapitulates everything that happens in humans. So out of this, you can see non-human primates, even though it's almost similar, it does not cause maternal death. The mouse, miscarriage can be seen, vertical transmission can be seen, but no maternal death. So recently, around 2017, they found there is a strain of Hepatitis E virus. It's called rabbit strain of Hepatitis E virus, which was shown to produce maternal death. So from here, what I want you all to say is like up to now, the nearest model that we can use is the rabbit. And that's also only specific to the rabbit Hepatitis E virus strain that produces pregnancy mortality. So just let's make a picture. What are the host factors till now the scientists have studied? Hormonal factors. During third trimester or during the pregnancy, we all know there will be upregulation and downregulation of various hormones in the blood level, so to maintain a pregnancy. So they have shown role of those three listed hormones in the replication of the Hepatitis E virus. Now, at the same time, the question would be coming in your mind. If a natural hormone is playing a role in helping the virus to replicate, how we are able to stop it? If you stop a progesterone during the pregnancy, the pregnancy will terminate. So such research are only just like you are giving a clue what's helping, but it's not like a solving what's happening. Second factor is immune factor. You don't have to remember those cells names, but just remember immune factors are playing a role in helping Hepatitis E virus causing pregnancy mortality in pregnant women. The third factor, viral factors. You may have remember I said there are some strains that get transmitted only through the contaminated water in developing countries. Some strains that only transmit through the contaminated meat and blood transfusion. So there is a viral factor that actually playing a role in the pregnancy pathology. The fourth one is nutritional status. This is so basic. We know like if the nutrition is low, immune system would be low, and the virus would get a higher chance for replication. So from all this, now I want to say you all what we do in Kenney Lab. So up to now, I didn't say a single word about chicken, and now you would be seeing why I have a chicken picture there and a human picture here with the liver. The reason for this is, as the name suggests, hepatitis, which means swelling or inflammation of liver, so there should be a liver pathology. But none of the model listed above show any signs of liver pathology. Even though rabbit produces pregnancy mortality, but we could not see any liver pathology. However, we have an avian strain of Hepatitis E virus, which produces liver pathology in chicken. So the idea started around like 2001. Can we develop a chicken liver model to understand what's happening in humans? So at that point, Kenney Lab decided, let's enhance the replication of the avian HEV. Let me tell you, avian hepatitis E virus do not infect humans. Do not infect humans. So when we enhance the replication of it, we could see almost similar liver lesions as humans. So from here, what we are trying to develop is like we are trying to develop a chicken liver model and use that chicken liver model to study what are the host factors that is helping produce liver pathology in humans. And now I will talk about immunosuppressed individuals. So I separated from a general population, pregnant, and the immunosuppressed. So with all the viruses, as my friend described before, just now about the diabetes and the SARS coronavirus too, you may have known like how immune compromisation or something that you are already having a disease, a virus would take over you. Similar like an immunosuppressed individual. When there is a solid organ transplant patient, so in America, we almost have 19,000 people waiting according to the 2020 list, waiting for the solid organ transplant. So whenever there is a solid organ transplant, the individual would be given the immunosuppressive drugs. So overall picture is the patient is immunosuppressed, which means the immune system is low. At that point, mostly the hepatitis E virus have been seen in those patients in most of the hospitals. During that point, the doctor will prescribe, okay, use the antiviral. And now what's happening is, instead of the virus getting cleared, virus is able to make a mutant. So it's a new variant that is seen. And most of the time, the ultimate goal is either the patient recovers or either there is a death. So what Kenney Lab is doing is we will be utilizing the pig model. We'll be utilizing a pig model. So how does that work? We will use the same drugs, immunosuppressed drugs that human use, and give it to the pigs. So the pigs will be mimicking an immunosuppressed human. And then we will check those HCV variants that have been seen in human and study its pathology and severity of the disease. And that's where my next project is heading on. With this, I like to thank you all. And before closing, I want to say, always prepare your food above 70 degrees Celsius, because that's where the hepatitis E virus gets killed. So when you cook food properly, you don't have to be scared about hepatitis E virus. And hopefully, we will never see hepatitis E virus making a big news if everyone starts preparing their cooked food properly. Thank you.